Good morning, all of you. I'm Dr. Raju Anita, Faculty for Artificial Intelligence. Today, we are going to learn the session number 8 from CO2. The session number 8 from CO2 is regarding to adversarial search. So, already in the last session, we discussed about the local search algorithms. Now, in this session, we are going to learn about adversarial search. What is an adversarial search and why we are going to learn this searching algorithms? So, especially this searching is we are using for game playing. So, adversarial is a game playing technique and where the agents are surrounded by the competitive environment. That means, suppose you are playing a game. How many players will be there in that game? Two players. We cannot say exactly two players. The two players game is there and three players game is there. Let us talk about the two players game. Suppose if you are playing a game and your two players are there. For example, I'm giving the name for you as Max. I'm the opponent for your. I'm the minimum. So what is your task? What you are trying to do? Always you are trying to win the game, and always you are and what is my job? I'm the opponent for the game. What is my task? Always I'm trying to lose the game of you. That means always I'm trying to decrease the winning chance of my opponent, and you are the player, you are always trying to increase the winning time. I'm the opponent for you, I'm always trying to decrease the winning chance of yours. So this is the concept you have to understand in adversarial search. So adversarial search is a game playing technique, as I told for you. Here, examine the problems that arise when we try to plan ahead in the world where other agents are planning against us. So here, what kind of games comes under this game theory technique? In game theory technique, the games which are comes under this theory is only the games which you are thinking or logically thinking with human intelligence or logically, but the games will not comes under game theory which are playing on luck factor. So because if you are going for tic tac toe or chess game, always you have to show your intelligence to win the game. But if you are falling on the luck factor, you never win that game. So what kind of games that it will comes under game theory? So the games which you are thinking or with which you are applying your intelligence, that it will comes under this game theory. Okay, so a good example is board games. That's what I said. Chess games or tic tac toe games or AlphaGo. These kind of problems will comes under this. So adversarial games, while much studies in AI, are a small part of game theory in economics. Yes, we are applying these techniques to play the games. And next, what are the typical AI assumptions? What are the assumptions you are having while you are playing your game? So the mainly we are having two assumptions. The first one is we are in the competitive environment. That means you are always trying to win the game. So the opponent of you always trying to defeat your game. That means always he tries to lose the game of yours. So that means he always try to decrease the winningness of the opponent, right? Two agents whose actions alternate. So how the game is played? First you are playing, next alternative chances you are giving for the players. You are the first player, next you are giving the chance for the next player. So alternatively the game is playing for two agents. Utility values for each agent are the opposite of the other. So what is the utility value? That is the final result is called it as utility value. So that is exactly opposite to other. For example, if you win the game, what is the status of mine? I lost the game. If I win the game, you lost the game, and there may be the tie also occur. So what are the utility values occurs here for a game? Either 1, -1 or 0. What is this 1, -1 and 0 indicates? 1 indicates win the game, and -1 indicates lose the game, and 0 indicates tie. The game is tie in between those two agents. create the adversarial situation. So here always you are creating the adversarial situation. That means one player is trying to increase the winning of the game, and one player is trying always decreasing the winningness of opponent. So these situations he has to create. Fully observable environments. Yes, this is fully observable environment, how the two agents are playing the game. So while they are playing the game, so they should give the chance for the opponent once his task is completed. In game theory terms, zero sum games of perfect information. We will relax these assumptions later. So we are going for these assumptions later. First, in as per AI assumptions, you need to understand about two agent games. In these two agent games, you need to understand the terminology max and min. What is the max and what is the min? And there is a difference between the search versus game. Search is different to game. What are the differences for search and game? In the search, solution method for finding a goal. So always you are finding the solution. And suppose I'm giving a tree here for you, and I'm asking, so I need to find out this goal. So what you will do, based upon the heuristic function or based upon the solution, you are going to find the goal. Next, heuristic techniques can find optimal solution. Why? What is an optimal solution? In the given set of feasible solution, you need to find one best solution. So how you are going to find the best optimal solution? With the help of heuristic techniques. So what is the heuristic technique? That is depends upon on which you are applying. So the heuristic value depends upon the problem what you are finding to optimal solution. Next, evaluation function. Estimate the cost from start to goal through given node. So this evaluation function is also depends upon the problem. So if you have a problem, that problem is having some evaluation function. You based upon the evaluation function, you need to estimate the cost of the problem. Next, for example, path planning, scheduling activities. These comes under searching techniques. And what is the game theory? So that is adversary technique. What are the adversary technique? Solution is a strategy that always the human is showing his intelligence to find out the solution, and optimally depends on opponent. So how you are going to take the decision while you are playing a game? For example, you are playing the chess game. So how your decision it will be, that is depends upon the opponent. If the opponent is starting his move, then based upon the opponent move, then you are going to take the decision. Time limits force an approximate solution, and there is a time limit. The time limit is also as a constraint. They will keep on a game. And next, evaluation function. Evaluation is goodness. Is the step is goodness, or is it is good for the game position? That means, is that step whatever you are taking is taking you towards to the win the game, or is that step is going to take you to lose the game? That is depends upon your intelligence. For example, what are the examples of adversary games? Chess, checkers, Othello, and backgammon, and AlphaGo. These are the different types of game theory techniques we are having. And next, what are the types of games? What are the types of games? These are the different types of games. For some games, we have the perfect information. Those are deterministic. Chess, checkers, Go, Othello, and backgammon and monopoly are the chance moves. Imperfect information. Some games they will give imperfect information. Under that imperfect information, some games comes as bridge and scatter. And for the chance moves, there is a poker, Scrabble, and blackjack. These are the different types of games we are using in artificial intelligence. And next, game setup. How we are going to make it set up a game? So here we are discussing about a two-player game. Max and min. Assume these two are the two players. Max is one player, min is the another player. Assume max is you and min is your opponent. Max moves first and they take turns until the game is over. So first we are giving a chance for the max. So the game has to be started by any one of the player. So we are giving a chance for the Max to play the game. So the Max is starting his first step and he continues his game until whether he win the game or he may lose the game. And next, Min is your opponent, right? So whenever the Max is taking a chance, immediately the next turn it will give for the Min, that is your opponent. Then Min will take the chance now, and always the Min try to decrease the winningness of the Max. So you have to understood these two, Max and Min. What are the tasks of Max and Min? Max is assume, Max is you. Min is the opponent. What is the your task? Always you are trying to win the game. That means always you are increasing the winningness of the game, right? Min, what the Min will do, always Min is trying to decrease the winningness of Max. So if you are going towards to winningness of the game, Min is trying to decrease the winningness chance of Max. These two tasks are performed oppositely, right? Next, games as such. Initial state. What is the initial state? Suppose you are taking a chess game. So the initial state of the chess game is board is configuration of chess. So you are keeping all the chess coins on the chess board. Successor function. List. What are the list of moves? So initially you should know what are the rules that you have to follow to play the game. That is list of moves. And terminal test. Is the game is finished or not? How could you say whether the game is finished or not? Who won the game and who lost the game? So what is the final state? So when you can say that you are win the game, that is depends upon the terminal test. Okay, next, utility functions. What are the utility functions? It gives the numerical value. When you can say that you are win the game, suppose +1 occurs, you win the game. And suppose -1 occurs, you lost the game. And if 0 occurs, then that is the tie was happening in between those two, right? Next, size of search tree. What is the size of the search tree? How could you find the size of a search tree? The first one is branching factor. What is the meaning of branching factor? The meaning of the branching factor is the number of children generated by that particular node is called it as a branching factor. And D is the number of moves, or we can say that the depth of the tree. What is the depth of the tree? How could you calculate the depth of a tree? The maximum distance from root node to leaf node is called it as the depth of the tree. So here B is the branching factor and D is the number of moves by both players. And next is search tree. What is the time complexity of this search tree? That is big O of B power D. This is the time complexity. So what this time complexity is calculated if you know the branching factor and the depth of the tree, right? So this is, for example, for the chess game they took as branching factor is 35 and the depth of the tree is 100. So based upon that they calculate the time complexity of this, and this we are applicable for real world agent problems. Next, this is an example for tic-tac-toe. How the min-max algorithm work for tic-tac-toe. So see here. Here how many players are there? Max and min. Two players are there. This is the max player and min player. The chances occur alternatively. First max player plays the game. Next min player. The next chance give for max, again min. So how long this game will be played? Either one of the player has to be win the game. So what is the initial state of the board? Initial state of the board is empty. So these all are empty blocks you can find here. So first chance I am giving for max. So what the max will do? He will use all chances where he want to keep his coin. For example, the max would like to keep the coin X in the box. So there is a chance for max he can keep X here and he can keep X here, X here, X here, X here, like this. So all possibilities he can take one possibility among these possibilities. Next we are giving for min. So what is the task of min? So always the min tries to decrease the winningness of max. So so that's why the min kept his coin here, because he want to decrease the winningness of max. See, he kept here like that. And the next chance is for max. So the max is keeping the next coin here. Always he is trying to win the game, and min is trying to lose the game of max, decrease the winningness of max. So finally terminal, also final terminal -1. That means who lost the game here? Suppose x max lost the game. So here in this situation, terminal, who is the winner here? Min is the winner. But who started the game? Max is started the game. -1, you are giving the utility value based upon the max. So here the max lose his game. So -1 was given. It's 0 because nobody win the game. So 0, that is the game is draw. And next +1, that means here who won the game? So you can see the diagonally he kept x's. So here the utility value, the terminal state is showing that the max is win the game. So the utility value was given the numerical +1. +1 indicates the winningness of the game, -1 indicates the loss of the game, and 0 indicates the draw of the game. Alright, and next, so it is showing how do we search this tree to find an optimal move. So here we are having so many moves that are existed. Then how he is going to find which move is going to be a optimal. So here what are the different chances to keep x here for max? These are the different feasible options are there. So in which option he has to choose, which path he has to choose to win the game. So this is the question for his, because here in this algorithm, in this play, we have to show for the max the optimal path. If you go for this path, there is a chance to win the game. That's what we want to show the solution for the game tree. So for that we are going for algorithms. That algorithm is min-max strategy. This is the algorithm. So we are having two algorithms to help for you in this regard. So the first one is min-max algorithm, the second one is alpha beta pruning. So we are going for the first min-max strategy in this session. So min-max strategy, what is the min-max strategy here? Find the optimal strategy for max assuming an infallible min opponent. So always you have to find a path, a best path. How you are going to find the best path? The maximum, always try to select the maximum value for the given tree. The minimum, always select the minimum value from the given tree. So if you follow these tasks, then you could be able to show the optimal path for a player who is playing the game. So assumption, both players play optimally. Yes, both players are play optimally, because both players are assuming that I want to win the game. The next opponent is also think that I want to win the game. So given a game tree, the optimal strategy can be determined by using min-max value of each node. That means in this min-max strategy, we are going to calculate min value and max value for each node. So based upon that min value and max value, we are going to direct the player which path he has to choose. See here. In this max and min, he is the one player max and this is the another player min. Right? This is the two play game. We can have not only two play games, some games are there with two play games and some games are there with more than two player. So here I am explaining the example of two play game tree. Now in this diagram, max, min and terminal, you can see the terminal values. So here you have the leaf nodes. This is the leaf nodes and this is the internal nodes and this is the root node, assume. So who started the game first? Max is started the game first, and next chance is given for min. So what are the leaf nodes contains? The leaf nodes contains 3, 12, 8, 2, 4, 6, 14, 5, 2. So now here this and one more thing you need to remember, this game tree, that means adversarial search completely depends upon depth first search. DFS. I think you are very clear about the DFS, depth first search. Which strategy we are using for DFS? Stack. Right. So from top root node 2, I am traveling towards to the last node. This is the terminal 3. I am coming here. So now here, from apart from 3, 12, 8, here who is playing the game? Min is playing the game. So from 3, 12, 8, you need to select the minimum value and give that value here. Which one is the minimum here? 3 is the minimum. So you can write the 3 here. And 2, 4, 6. Which one is the minimum here? 2 is the minimum. So you can write 2 here. And 14, 5, 2. And which one is the minimum here? 2 is the minimum. So you are writing 2 here. So apart from these 3 values, the max has to take the maximum value. So here, if you see this diagram, from this the minimum value is 3, and this is the path. And you can assume this, the nodes are treating as states and the path is stating as the move. So here A11 move, A12 move, A13 move, A21 move, A22 move, A23 move. So like that you can assume. Otherwise you can assume that A11 move, A12 move, A13 move, right? Here 3. So 3 is the minimum here. You are placing 3 here. And 2 is the minimum. 2 is, you are writing 2. And here 2 is the minimum, you are writing 2. And here 3, 2, 2 I have. So what is the turn for max? Max is the turn. So max, what it will decide? So are you observing here? We are going for backwards. That means we are applying the backtracking technique in the game theory. So you have to remember that we are applying the backtracking technique and DFS in the game theory. Right, and here 3, 2, 2 is there. So apart from this 3, 2, 2, which one is the maximum? 3 is the maximum. So 3 is assigned for the max. So the maximum value is the decision 3 is. So we are giving that player max. You can select the path, the 3. So which it leads to the chance for winning the game. So we are directing the max. If you choose this path, there is a chance for you to win the game. That's what we are showing you with this min-max algorithm, right? And what if min node does not play optimally? So as per the definition of optimal play, max assumes min plays optimally. So maximize worst case outcomes for max. So what is the worst case? If the min does not play optimally, what is in this situation? So we are going for the next one is alpha beta pruning. So I would like to give one example here and one more example here for min max algorithm, how we are going to play. And you please observe this. I would like to take one example and I will show you how to min-max algorithm it works. I'm moving for the board. Please wait a minute. So here I want to show you how min-max algorithm works for the given list. So here one example I'm considering for min-max. So here I'm taking, this is the node, right? This is a node, right? And here I have nodes like this, and this is next here terminal. So what is the terminal here? I'm giving values. Here I'm giving 4 minus 9, and this is I'm giving 33, and here I'm giving 12, and here I'm giving 32, and here I'm giving 13, and here I'm giving the value 9 and minus 2. 9 and here I'm giving, okay, 2 I'm taking. So first I'm giving the chance for max, and this is mean, and again we have to give for the max. So right, this is the way how we are playing the game. So how you are applying the minimax algorithm here? First you are going towards to, so here we need to direct for the max which path he has to select to win the game. So from this you have to go for first towards to the terminal. So because DFS, we are following the strategy DFS. So we are following up to the terminal node. So 4. We are having here 4. So here who is playing? Max is playing. So what is the maximum value here? 4 and minus 9. 4 is the maximum value. And what is the maximum value here? 33 is the maximum value. And here 32 and 30. Which one is the maximum? 32 is the maximum. Right? 32. 9 and 2. Which one is the maximum? 9 is the maximum. That means you are backtrack. You are applying backtracking technique here and here. Next, so who is the playing here? Minimum. So from these two, it has to select the minimum. So which one is the minimum? 4 and 32. 4 is the minimum. You are writing 4. 32 and 9. 9 is the minimum. So it is writing the 9. So next, next you are going for backtracking again. Who is the playing the game? And who is playing the game? Max is playing the game, and it has to 9. So this path has to select. So to win, there is a chance for Max if we select this path. So we are directing to the Max. If you select that path, there is a chance for you to win the game. Understood how the min-max algorithm is applied for the given example? And we are moving next slide. So here based upon that, see this pseudocode for minimax algorithm. So in this minimax decision, so how we are going to take a decision? Returns an action. Which action it has to take? Inputs. What are the inputs you are giving? The state, current state in the game. What is the current state of the game you are giving? So first of all, you are assigning the maximum value of the state to the V, and you are returning the action in successor state with value V. So what are the successor states? Those you are going to return. Next, this is a function, and max value state return a utility value. So what is the utility value? The final output. What is the final output of that? I was given here 9. I was given here. So that means you are selecting that path. The utility value is the final value what it was taken. And terminal. So whenever you are reached to the final state, it will return to the it will return the utility value, and it will decide whether that player win the game or lose the game. And first you are assigning minus infinity to V, right? Because for max you are assigning minus infinity. For min you are assigning the infinity. That's what we are doing here. That it will comes very clearly for alpha beta pruning for you, which we are going to discuss in the next session. For A and S in successor state, do what you are going to do here. I want to decide what is the maximum value from the current to the min value of each. So that value you are assigned for V, and that value are returning. That means you are selecting that max value, and this is a function for min value. Min values always try to find out the min value in the given current state, and you have to observe here. So if you are trying to find out the max value, that value initially it has to assign minus infinity, and if you are trying to find the min value, you have to assign infinity. Because what is the task of max player here? Max player always try to increase the winningness of the game. Suppose I am the max player. What my task is, I am the first player in my game, and I am the max player. What is my task? Always I am trying to win the game, and minimum you are the opponent for the game. What is your task? Always you are trying to decrease the winningness of mine, because if you are trying to decrease the winningness of mine, then automatically you will win the game. So you need to remember that if you are finding the max value, that V has to be assigned minus infinity. If you are finding the min value, you have to assign the value as infinity, right? And next, see the another example of algorithm execution, how it will be executed. So what is here? Terminal values plus 10 plus infinity, 5 minus 10, 7, 5 minus infinity, minus 7, minus 5. So we need to start here our max to move. So first the chance is for max, next chance is for min, max, min, max. So first it is going towards to the last terminal depth first search. So it is moved to the terminal node. So this is a leaf node 10. So here which one is who is playing here, you need to understand. So the first player is max, the second player is min, next max, next min. So which one is the minimum? 10 and plus infinity, plus is the minimum. So it was given plus, and 5 is the minimum, and minus 10 is the minimum, and 7 5 is the minimum, and minus infinity is the minimum. Minus 7 and minus 5, which one is the minimum here? Minus 7 is the minimum. So next, after playing the minimum here, the next chance is given for maximum. So 10 5, which is the maximum? 10 is the maximum. Minus 10 is alone here, minus 10 is the maximum. 5 and minus infinity, 5 is the maximum, and minus 7 is the maximum. And next here, who is playing here? Minimum is playing here. So he has to select the minimum value of the each node. So 10 and minus 10, which one is the minimum here? Minus 10 is the minimum. So it's selected as minus 10. And 5 minus 7, which one is the minimum? Minus 7 is the minimum. He selected as minus 7. So who is the playing first started game? That is max. So he has to select which is the maximum value in the given nodes. So minus 10, minus 7. Which one is the maximum value? Minus 7. So minus 1 is selected. So which path the max has to select to win the game? This path has to be selected. So the blue arrow indicates this is the path the max has to select to win the game. This is an optimal path we are giving for the max to win the game. Next, Minimax algorithm is a complete depth first exploration of the game tree. So as I told for you, Minimax is completely depends upon the depth first. And here the time complexity is big O of B power D, and space complexity is big O of BD. So what is the main drawback of Minimax algorithm is, so as you know, if here unnecessary searches is going on. So that means it will take more time for us to give an optimal solution. So because it is searching for each and every path. So to reduce this drawback, we are going for the next algorithm, alpha beta pruning. So in next session, we are going to discuss about alpha beta pruning in the next session. So good luck. If you have any doubts, you can post your doubts for the next section, right? Thank you.